So today I would like to present my research topic on the biochar for metal removal from the wastewater. So in this presentation I will start with the introduction and so on until the conclusion. So first, to begin, when you want to produce the biogas production, you always familiar with this anaerobic digestion process. So normally, anaerobic digestion process, the aim is to produce the biogas, which is the methane as the main product. And they use the organic waste as feedstock in this case, for example, municipal solid waste and sewage sludge. And after we use these waste as the feedstock, then we get the biogas. However, then we also get the byproduct organic waste as well. In this case, it is solid digestate, such as organic fraction of municipal solid waste digestate or sewage sludge digestate. So since these digestate, they contain some metals and also pathogens that cannot be directly applied to land or to the agricultural purpose. So we try to make use or recycle of this waste. So here we try to coupling between the digestate production and the biochar production with the slow pyrolysis. Under the slow pyrolysis technology, then we can produce three main products, which is syngas, bio oil, and biochar. So when we coupling these two technologies, then we can add more products, add value to the product. And in this research study, we will focus on only the application of the biochar. So just to give a brief detail, what is biochar? So it's a solid char that derived from a thermal conversion process of the carbonaceous solid material. So thermal conversion process, there are many processes, for example, for the hydrothermal carbonization, gasification, or pyrolysis. And in this case, we select the pyrolysis. And we undergo the pyrolysis with the control of the limited environment. So basically, the biochar can be produced from many types of the waste. For example, from the agricultural waste, like the rifles, switch glass, bagasse, and hardwood. But in this study, we focus on the waste from the industrial sector, which is the solid digestate. And then after we undergo the slow pyrolysis, then we get this biochar. Normally, slow pyrolysis, they are operate 300 to 500 degrees Celsius. Within time from 15 and can be up to 1 or 2 hours. So normally there are four main aspects for the biochar application in the environment. So for the carbon sequestration, used as a bioenergy or used as soil promoters to enhance the soil fertility, and last aspect for to immobilize the contaminant. So for the carbon sequestration, but if we apply the biochar to soil, then the biochar can capture carbon dioxide emission from the soil to the atmosphere, and as a result, it can reduce the greenhouse gas emission. And for the bioenergy, it can be produced and pyrolyzed into into the pellet or the brick, so that it can be used as a cooking fuel for the some developing countries. And also, yes, since biochar they have some porosity and suitable or physical-chemical properties, so they can hold some water or even capture some nutrients, so that can be slowly released to the soil, and that it can enhance the soil properties. And last aspect, it can be used for the contaminant immobilization. Used to here, for example, here they have more porosity, so that it can be used to absorb the metals or even the organic pollutants. So in this study, we will focus on the application of biochar for the last aspect. So just to give you a detail about the sorption mechanism that can take place between the biochar and the metal. So basically, there are four main mechanisms that can take place. So surface complexation, that the metal do the complex with the functional group on the biochar, and for the physical absorption, it can take place via the electrostatic interaction, And for the cation exchange, they can indicate the exchangeable metals such as calcium and magnesium that can be exchanged with the metal. And last aspect for the surface precipitation, since some biochar sometimes they also contain the phosphate and carbonate. So if the biochar contains these elements, this compound, then the precipitation can be take place. So in order to be able to understand the mechanism, so we try to link the physical chemical properties so that we can predict or try to understand the sorption mechanism. So in this case, we have a pH of 0.0 chart, the cation exchange capacity, and specific surface area. For the pH of 0.0 chart, it is an indicator that it is useful that we can help to select whether this biochar is suitable for the positively charged or negatively charged pollutants. For instance, if the pH of 0 chart increase, so meaning that the biochar will have more positively charged on the surface, so that it can attract more the negatively charged ions such as the arsenic. And for the cation exchange, so we can use cation exchange capacity parameter, so that we will know that the ability of the exchangeable cation that then can improve more the sorption of the positively charged metal. And lastly, surface area, then we can know the more available active foresight that can be suitable for sorption of the pollutants. So now for the biochar application for the sorption of metalloid. So normally cadmium, it can be found in many sources, but mainly from the industrial side, from mining, smelter, wastewater, and so on. While for the arsenic, normally arsenic in the past they have used as a pigment and was a preservative. But then when people figure out that it's very toxic, then they are banned now. But since these elements they are persistent, so they are still continuing to stay in the environment. Particularly in groundwater, as Bangladesh, China, and India, they have a severe problem of these pollutants, and these metal and metalloid, they share the toxic and carcinogenic properties. So the objective of this research, we try to produce biochar from the surplus digestate and use it as a solving material for the metal and metalloid. So the subtopic is we try to observe the chain of physical-chemical property after we do the chemical treatment. We also try to investigate the effect of a chemical treatment and washing procedure to see whether it affects on the sorption ability toward metal and metalloid. So here just to show you the overview of this study. So there are three main steps. So first, when we got the biochar, then we make the chemical modification with these two chemicals here. And after we do the chemical treatment, then we undergo the batch the batch washing, as has been reported in the literature, meaning that they are washed the biochar in a batch until the pH becomes stable. But however, since in this study, we found that the biochar are able to release some compounds. For example, dissolved organic compound, carbonate, and phosphate into the solution, meaning that if we would like to study the sorption, it will disturb the sorption. So what we do is that we try to implement the batch, and then we subsequently wash in a column, so that we can eliminate all of these released compounds, and after that we paste on the sorption for the metal. So here, in this case, this is a series plus digestate here. So we produce in the industrial scale by using the bio-green technology under 350 degrees Celsius with a residence time of 15 minutes. So here we shoot the hydrogen peroxide and potassium hydroxide, because hydrogen peroxide, it can increase the surface carboxyl group of the biochar, while the potassium hydroxide, it can increase the surface hydroxyl group and basicity of the biochar surface. Yes, and as I mentioned earlier, we have two types of the biochar, with the only batch washing and the batch with the subsequent column washing. So now come to the characterization of the biochar. These are the parameters for the biochar, and the last three that is involved are the main parameters that can be linked to the sorption. So for the pH of biochar, there are many methods that we can use, but in this case we use the theta potential. And for the carcinogenic capacity, we measure absorbency when for the surface area we use the nitrogen sorption. And now here is just the information about the experiment for the sorption, kinetic and isotherm. To move to the result. So this is the monitoring of the column washing. So here, this figure they show the evolution of the pH and conductivity along the washing time. So at the beginning, it is the batch wash, and after we wash along the time. So at the end is column wash. This is the KOH modified and this hydrogen peroxide modified biochar. We found that there are decreased trend of both pH and conductivity, and it stabilized in 70 hours. And also we also see the evolution of this release compound as well, and it also decreased along the time, and it is the trend is consistent with the conductivity, meaning that conductivity is a key parameter to monitor the washing. And the KOH is harder to wash than the hydrogen peroxide, because if you see that at the beginning they have very high concentration of this release compound compared to hydrogen peroxide. Sorry, I just move very fast because due to the limit time. So effect of biochar washing. So here it shows the sorption kinetic result. So for the case of cadmium and arsenate or arsenic 3, so it slightly affects, as you can see that it reached equilibrium, very similar. While if you see for the case of arsenate or arsenic 5, it's a much slower kinetic induced by the additional column washing. Here you can see that grade 1 is the column washing, and this is the batch washing. You can also see from the K2 value that it's higher, it's lower with the column washing. And this is the result of the sorption isotherm here. So here you can see that the maximum absorption it's similar for the case of cadmium and arsenate. While for the arsenic 5 or arsenate, the sorption capacity improved by around 10 times when we use the column washing. So meaning that column washing is important as it can affect the sorption for the metal, particularly for arsenic 5. And then we select the column washing to study the effect on chemical treatment. So here is the effect on chemical treatment on the sorption kinetic. So here we found it for the cadmium, the chemical induced faster kinetic rate. As you can see that it reached equilibrium real fast compared to the raw biochar. While for the case of the arsenic 5, we can see that when we modify with hydrogen peroxide, it's really similar, no difference change. While for the KOH, it's a slower rate was found. This is linked to, we see that for the pseudo second order model and intra-particular model, if we observe the relative coefficient, it's really similar, 0.995 and 0.993. So meaning that the intra-particular division can also involve in the arsenic. And now going to the absorption isotherm on the aspect of chemicals. So we found that for the when we modify both with the hydrogen peroxide and potassium hydroxide, it significantly improved the maximum absorption capacity. As you can see from the curve, that this is the raw biochar, and this is with the chemical. And it is more improvement, more important than for the case of cadmium than the arsenate. As you can see, it is really improved compared to this one. And we try to link to the evolution of the biochar properties. So we see that here we found that with the chemical treatment, it helped to increase the pH of biochar, calcination capacity, and specific surface area, meaning that then it can, for the higher pH of biochar, so it increased the positively charged on the biochar surface, so it can attract more absorption for the arsenic, negatively charged metal. For higher carcinogenic capacity, so meaning that if this one is higher, means that then it can absorb more positively charged metals. also more surface area, so there are more active parasites on the surface of biochar that can be available for the absorption of the metal. And now come to the conclusion. So for the absorption kinetic is well described by the pseudo second order model, while the isotherm is well described by the Langmuir model. And also the intraarticular diffusion, it involves for the case of arsenic 5. And in this study, we highlight that the column washing is important. When we do the washing of the biochar with the column, the absorption efficiency of the metal is improved a lot on the biochar, particularly with the TOH treatment. Also, electrical conductivity is a key parameter to monitor biochar because from literature they only mention that they use the pH to control the washing, but then we found that the only key parameter is the electrical conductivity. And with the chemical treatment, it can induce higher maximum absorption capacity of cadmium up to 20 minutes, for the arsenate up to 5 times. And the pH is better than hydrogen peroxide, and this result is correlative with the improved properties of the biochar. And this is the end of my presentation. Thank you.
Thank you, Suchanya. Maybe we have time for only one question for her. Maybe two questions.
Actually, this presentation reserved questions. So it was very elaborative presentation and very nice figure, and everything was very nicely explained. Congratulations for that. What I have one theory and then question. One theory is that how did you balance arsenic 3 and arsenic 5? Yeah, I mean the arsenic 3 and arsenic 5, you have performed the experiment separately. How did you do that? Because arsenic 3, yeah.
Normally if you want to measure the total concentration, so you use the ICP-OEF. But then if you want to measure only arsenic 3 or only arsenic 5, so you have to use the special technique that can differentiate the species. So in this case, I use the HPLC couple with the
my point is that even if when we put arsenic 3, because you have to take some salt for arsenic, for absorption, you have added arsenic, right, into the system.
Arsenic, yes, arsenic 3 and arsenic 5.
Yeah. So when we add it, it gets oxidized, or the arsenic 3 becomes arsenic 5. And that's why in the conclusion, you have not told anything about arsenic 3.
Actually, because I have made sure that, when I do the experiment, I also check whether they are the oxidation of arsenic 3 to arsenic 5, or from the arsenic 5 to arsenic 3, I have the control of the solution itself to ensure that there is no problem of this issue. Yeah.
Thank you, Doctor. Doctor, I have one question left regarding the functional group. You have mentioned earlier, first or second slide, about the mechanism. Yeah. But in your work, did you check which functional groups were involved in this mechanism? Because you said to the second order was involved in absorption mechanism. But which functional groups did you find out in the end were involved in absorption?
Actually, I have not looked into detail of that, but since the data say that it fits to the pseudo second order model, and sorry, I didn't understand your question exactly.
Because you said pseudo second order model was the one which explained the data very well. So it means chemisorption happened. If chemisorption happened, then what were those functional groups involved in the sorption of metals which you were studying in this work?
Yes, because actually for the pseudo second order, it theoretically say that it's chemical absorption, but it cannot prove that is show that chemical absorption can be, only take place. But in my case, since I found I tried to link these parameters. So basically, there should be the physical absorption that should be take place for the metal and biochar, also the cation exchange, and also the surface area can, the metal can be solved to the pore side of the biochar. It's just a possibility, but if I want to be sure what is the real mechanism, then I have to do the further study. For example, to do the modeling, we have to see exactly the mechanism. This is just to try to explain the possibilities of the mechanism that can be take place by using, try to link the physical and chemical parameters.
Yeah, exactly. That's the reason we study pH, ZPC, and other things, cation exchange and other things. But don't you think we should consider FTIR for this? Thank you.
Yes, actually, I have measured the FTIR as well from the biochar before and after the sorption. Yes, but in my case, it does not show the significant result as the peak is, it's not so much different, it's similar. So I don't think that it is the main mechanism that takes place. Maybe another mechanism is more important than the sorption by the functional group.
Okay, thank you, Dr. Suchanya. Again.